Ed Popcom once told me, we're all standing on the shoulders of others. Indeed, I owe a great deal to those who have gone before, or those who worked with me. My mentor at Harvard was Howard Fisher, the founder of the Lab for Computer Graphics, someone who I believe has not received his recognition that he deserves. Therefore, I'd like to take a few minutes to talk about Howard, if I may. Howard was a graduate of Harvard College in 1926. Then he went on to graduate school design, study architecture for 3 years. He left after that to thinking about problems of prefabricated housing using metal construction and mass production. He spoke to the Pullman Car Company and said, you folks have a lot of experience in building houses on wheels, if you like. What can you help me learn about how I can apply this to building homes without wheels? Well, he also approached other firms, such as those who are involved in plumbing or millwork, glass, insulation, and such. And by 1932, he had a new company set up, which he established, called General Homes, to build prefabricated, mass-produced metal homes of the type you see in the illustration there. By 1933, he had a 2-bedroom house on the market at $4,500. Remarkable. Being built with metal construction on a mass production, prefabrication assembly line. Recognition of that work, he was made a fellow of the AIA in 1974. Well-deserved, late recognition. Later on, Fisher became interested in city planning, his home base originally, and the use of maps. He became a member of the faculty at Northwestern University in the Technology Institute. And he taught subjects there in civil engineering and problem solving in general. While there, he attended in '62 a course at the University of Washington offered by Edgar Horwood on his mapping system called Map 01, using map on 1401 computer to make some of the first maps. Fisher thought, interesting, but like other ideas, I can even improve on that. I think he went back to Northwestern and working with Betty Benson, a programmer there, he developed the first version of SIMAP. The SIMAP was, he thought, something he could use in his consulting practice for city planning in Chicago. And at that time, he was also approached by the Ford Foundation and said, we'd like to support your work. We think it has real promise. Well, I had met Howard at this workshop in New Jersey at the AIP meeting, and I also enrolled in his correspondence course. You could take it by correspondence or by the Tuesday workshop. At that time, I was working in Louisville, Kentucky as a planner, my first job out of school. And I learned later Howard was approached by the Ford Foundation and said, we'd like to support your work. We think it's got real potential for planners. And at the same time, Ford also approached other people, such as my subsequent co-worker at Michigan State University, who was doing a project on gaming simulation for mapping, for planning. And I went to join him there, Richard Duke, and I also bought SIMAP and got it running on the CD3600 at Michigan State University. My job at Michigan State with Richard Duke and his gaming simulation project was to create a gaming simulation model which would represent the growth of the urbanized area over time. And I said, well, in order to communicate this to the game players, let's show them graphically. Let's make a film, perhaps. Let's make an animation. How Lansing grew from 1850 to 1965. I went down to the state registry and with a bunch of students, and we recorded all the information, every single subdivision, 1850, 1965, where it was located by section, range, and township. And they could then compute for every single section, range, and township how many subdivisions had been developed there and what percent of land was now in the subdivision as a measure of the urban development. And I filmed that as a time-lapse film, which I'll show you a version of here. It's an interesting film because it shows how the growth of an urbanized area, in Lansing's case, is very dependent upon the transportation pattern. It shows how Lansing starts out as a very nuclear city in 1850, a very small, compact area, and it grows out kind of linearly along the urban transit line, and then turn of the century with coming the automobile. Oldsmobile was built there, you know, up until this year anyhow. And it grows out in a very linear fashion. And then after the Second World War, it just explodes on a screen. It's very dramatic when you see it in the film. Well, by 1965, Howard was at Harvard. He had taken his promise of a grant from the Ford Foundation and was made a professor in city planning at Harvard. in the spring of that year. By the fall, the grant arrived. He had $300,000, a little more than that, from the Ford Foundation to start the lab going. Then he had to find some way of building that lab and staffing the lab. He did two things. He had lunch at the faculty club. He'd invite people to come in, geographers, city planners, architects, others who might be potential staff members, and they could talk about their work there. He brought in Bill Warrant, he brought in myself, he brought in Carl Steinitz, many others to talk about their work. He also involved freshmen in the freshman seminar series. He would teach freshmen the CMAP process and how they could then use CMAP for their own interest and their own applications. In the process, he got many very valuable contacts with freshman programmers, made very effective later employees of the laboratory. Here's an example of the correspondence course products or materials being developed at Harvard now. He brought them from Northwestern. We started them. Now they're at Harvard, and they're being worked over by the Helen Mansfield, who was director of publications there at that time. And one day, Howard got a phone call from someone in the state. They said, "We intend to offer you a correspondence course." He said, "Yes, I am." He said, "Stop." I said, "I beg your pardon." He said, "You cannot offer a correspondence course in Massachusetts unless the state approves it first. You must cease and desist." Howard was livid. He said, "No way, forget about that. Harvard was here before you were here, Massachusetts. Therefore, we're not going to worry about your problems." And they went away. A few words about CMAP. It made very effective, very low cost, very rapid maps, the kind you see here, maps of both data zones and contour maps, which were unique. You could also make maps of any other size you specified. For example, you can make maps which are twice that size. Here's a map of Bangladesh and India at a 2 feet by 2 feet scale, of population density done by one of the staff at Harvard. Here's a map that's 5 feet long of Delmarva, made by David Sinton and Carl Steinitz, using a variation of film called GRID, which was their version, which was scientifically working with gridded data as opposed to either polygons or contour lines. Now, contour maps are nice, but if you can't see the information that the contour represents, if you see the surface in perspective view, it's probably more informative, obviously. And we were able to get a program from Frank Renz at the University of Michigan, working with Waldo Tobler, came to Harvard, and we then began modifying that program further. But it's very effective for large data sets. For example, showing US population density is very valuable, as opposed to a contour map. This information is almost unintelligible. You see it in contours, see it in the surface, it's much more dramatic, much more informative. Towards the end of Howard's life, he was working on a book on graphic display of information. He was interested in particular on the role of the map maker in relation to the map sponsor. It was who's specifying that map's content. He said it's important to not only have the map designed to look good, but it has to have a message, has to have a purpose in its design. The form should follow the function of the map. He also pointed out the need to be aware that maps can lie. He said someone should write a book about how to lie with maps. He didn't do it himself, but said someone should. And indeed, must be aware always of the ethical issues of maps, that they're not misused for the wrong purposes. The most important thing we did, though, as far as research, was our work in data structures. Building upon the work of the Census Bureau in the dime file process, we were able to actually develop complete mapping systems which have topological structure to them, which allow us to do such things as polygon overlay for the first time. We had a project with the Defense Mapping Agency. They said, we have this data set which shows land use in one data set, floodplain boundaries in a second data set, and contour lines in a third data set for elevation. He said, we want to be able to combine these and then extract data by using set theory and selectively extract and analyze the data. We can't do that. We can try that, and we did, and we would do it successfully. It's the first successful use of polygon overlay on a vector data set to our knowledge, and to their knowledge as well. Very proud of that project. It was one of our most successful and dramatic benchmarks we had for Odyssey software. Well, several laboratory members are here today, as Jack pointed out, and they are far more important than any products we had, the people and their ongoing contributions to the field. And I'm going to thank them all today for all of their contributions.